In situ contaminant remediation, pump and treat versus enhanced remediation. A contamination source has been found in the subsurface. The groundwater is near the surface, and the contamination is in permeable sand and gravel. The contaminant is shallow and a non-aqueous phase liquid, a NAPL. The NAPL could be a chlorinated solvent such as trichloroethylene or a petroleum product such as diesel or gasoline. The contamination partitions into the groundwater at a slow rate, with the majority of the contaminant mass remaining in the source area absorbed into the soils. Even at the slow rate of dissolution of contamination from the source area into the groundwater, enough dissolved contamination causes risks to human health and the environment. Initially, recovery wells are designed to create a cone of depression and radius of influence that prevents the dissolved portion of the plume from continuing along the natural groundwater flow path. These systems are simply pumping contaminated groundwater to a treatment system. They do not directly remediate the contamination source, which has the majority of the contamination. These systems are referred to as pump and treat. Even when these systems can be shown to steadily decrease contaminant mass, they only do so at the rate the contamination enters the groundwater. These systems may require decades or centuries of operation to clean up the contamination, which makes a poor long-term solution. Enhanced remediation systems often focus on the contamination source that is not dissolved into the groundwater. The goal is to remove the contamination source. This is often done by injection fluids, which enhance the degradation or mobilization of the contamination. They often augment the pump and treat system and can be installed as the next step in cleaning up the contamination. The injection fluids are used to influence the contamination source. Methods such as enhancing biological degradation, adding bacteria to the subsurface, increasing contaminant dissolution, or increasing oxidation rates can be chosen based on specific site details. Multiple methods may be chosen in a staged fashion to reduce overall contaminant mass. The installation of vertical wells, infiltration galleries, or horizontal wells are used as injection methods. Here, we illustrate an injection gallery which involves excavating a pit, installing distribution piping, and backfilling with porous media such as sand, gravel, or tire chips. An injection gallery allows an even distribution of the injection fluid above the contamination source. We have chosen to inject a surfactant, which is increasing the mobilization and dissolution of the contaminant mass, leading to an increase in contaminant mass recovery at the recovery wells, and enhancing the availability of the contaminant mass to biological degradation. Now we will illustrate a horizontal injection system which is installed when an impervious surface or existing structure prevents easy access to the radius of influence above the contamination source. A typical scenario is illustrated where a leaking underground storage tank has been abandoned in place. The horizontal injection system can be installed with horizontal drilling techniques which install perforated pipes above the contamination source. Enhanced remediation systems are designed as a progressive attempt to reduce environmental concerns and prevent the legacy of contamination from continuing for future generations. They can often augment pump and treat systems, but involve in-depth evaluation of suitable technologies, the specific nature of the contaminant, and risk potentials due to mobilization of additional groundwater contamination.